as we get started today in the notes and the practice, not just the practice.
Are we starting in the notes today?
We are. We're going to be on the front of the notes today. And so, yesterday, we chatted a little bit about perfect squares. And then seeing what if they can divide into other numbers. Now, you may notice a couple of things that are a little different between what we've got here for the list of perfect squares and what we had yesterday. The list is shorter. We might expand this a little bit. But we've had a number disappear. 1 is not in our list. You're like, why is 1 gone? Is it like not a perfect square? It is. But when it comes to breaking down or simplifying radicals, 1 doesn't help us. So we're not going to list it. However, okay, what we are going to do is we're going to mess with this a little bit. So on this note packet as we started, we're going to box that in. And what we're going to do, right above it, is put the number that we're squaring to get there. So up above, we're just going to list off so if I take 2 to the second power, 4. If I do 3 to the second power, I get 9. If I do 4 to the second power, I get 16. And so on. Because, yes, we have a calculator. Yes, we're going to use it. But sometimes just having those numbers there might make my process go faster. So, today we are going to be simplifying. And I will make sure it stays on the screen here. We are going to be simplifying radicals. So, I'm going to talk real quick about the fancy language that's here, but then we'll put it more into something that's more like regular English. So, break down the radicand, there's a big word for today, the number that's underneath your radical, into 2 numbers. But one of the numbers must be the biggest perfect square that divides into the radicand. So, the reason I'm going to mention that is yesterday when we were working, that basically is what we were doing. We were finding a perfect square that divided in and finding the other number. So now, we're going to take one extra step today. So let's do step 1 on this first example, and then we'll go from there. So, just like we did yesterday, we need to find in this purple box, our purple perfect squares, we need to find one of these, the biggest one in the box that divides in to 20. And some of you are paying no attention to the fact that I'm saying in the purple box, not the pink numbers, just these. Well, okay. Ooh, I'm hearing lots of good stuff. Now, remember, with this, listen for a minute. With this, the number that's here, it can't be a number bigger than 20. Like 25 would get me a decimal. So it can't be, it's got to be one of these. So if you're trying them and you get a decimal, we keep going until we find, ooh, there's one that's not. So 4, I'm going to use my purple because that's the one that's going to break down here. Okay, so 4 and 5. That's my first job. So we're just going to be using the numbers in the purple box to divide in. Square root the perfect square and put this number in front of the radical. Okay, so my number that I boxed in, we're going to do the square root. You're like, okay, now how do I do square root? To get the square root, we're going to do second and x squared on these calculators. So here, for instance, if I want to do the square root of 4, I do second and x squared. There's my square root. Just the purple one, because that's going to come in nice. So what happens now is I end up with 2 times the square root of 5. We did the square root of 4. The square root of the perfect purple is what we're looking for. And we're, like I said, we're going to do several so we can kind of get used to the idea of this. So this is one of those, again, you're not going to be able to go in and out. So if we're going to text, Snapchat, whatever fun thing you do these days, TikTok, cat videos, whatever they are, cat videos, it's not going to work. Now, I don't have time for all that crap. So whoever's watching this later is going to be like, what is this guy? Oh, I'm just... So, again, let me get rid of these for a minute so we don't get confused here. So we're looking for the biggest number in the list. Now, it's got to be less than 32. So we'll cover those up too. We're just going to start dividing those numbers in the box in until I get one that goes in nice. So here's how this is going to work. So I've got 16 and I've got 2.
It's 4 squared root of 2.
So the square root of 16, second x squared, just the one that was in the box, that's the only one we're taking the square root of, is 4. And the other one stays as a radical. Good question. So the question that came up was, hey, that 4 is still a perfect square. Can I break it down further? So here's the way I like to look at it. When we start the problem, these numbers are in radical jail. However, 16 gets out of radical jail on good behavior because it acts perfectly like a perfect square. Once you're out of radical jail, we're not breaking you down anymore. You're good. You're out. So we're only going to break them down once. And it's only going to be the one that's the perfect square in our list that we're going to break down further. So let's play again here. I look at the next one. I'll come over on this side.
It should be multiple.
And again, if you think you know which one it is right away, you can go to it. But otherwise, we're just going to start working our way down the perfect purples list until we find that one that goes in. Okay, they're still both radicals at this point. But then the perfect one, and I'm going to show you a little secret here in a minute. Again, the perfect one gets out of radical jail. The other one is still acting irrationally. It does not. So, just something to mention. When I did this pink stuff at the start, notice something. The square root of 16 was 4. The square root of 25 was 5. The number that we put above is the square root of this number. You can still use the calculator. That's fine. I'm not going to take it from you. But if you're looking for a faster way to get done with some of these, that's how you can do it. Once your perfect square is found, just look above it. That's the radical part you're going to have. But it's only the perfect square, okay? Only the perfect square that gets to break out. Now, there's one other piece to the puzzle. And I want to do some of the practice ones with you too, because this is new. We're getting used to it. Multiply the outside numbers together. Hardy, what are you talking about? Okay. I'm not worried about the 5 at the start of this. We're gonna ignore that. That's not there at the start. We're going to mess with the 8 here first. So you're like, Hardy, the only number in the list less than 8 is 4. Okay, then that's what we're doing. So 8 divided by 4 is 2.
Then you still do it.
My 4 is the perfect one, so that's the one that breaks down.
And then you multiply the outside number by outside.
Right. Once we break that down, okay, then that 5 comes back into play. Multiply the numbers that are not in radical jail. Well, no, the 4 was the square root this time. Okay? Yeah, the square root will be broken down once. Then we just multiply the numbers that aren't in radical jail together. It's not in radical jail, don't do it. If it's in good behavior, we're not messing with the numbers that are in good behavior. We leave them be. They don't need to be changed. They're doing all right. Sure. And so when we keep working with these, you're like, woo, 500, what the heck? Okay,
Big number.
big number. So we'll start with our biggest one.
What's the 10? Wait, what's the 10?
250 is not a perfect square. But yeah, there are some bigger perfect squares. We'll deal with them down the road.
400.
Not yet. But here, right, we've got 100
And 5.
and 5. We're just seeing what divides in, what's the answer. The 100 is our perfect square, so it's going to break down nice. Oh dear. Oh, there it is. He gone. All right. Get breaking news in the middle of math lessons. I'm like, what? What the heck? Okay. So we broke down our 100 to 10. And again, once we're broken down, the parts that aren't in the radical, that aren't in radical jail, they can hang out. We can multiply them together. And get to my solution. And work it that way. So, as we're doing these, that's going to be your biggest thing. Reminding yourself one of the numbers that you're using to break down this radical has to be, no option, has to be in the purple box or whatever box you're using there, okay? I just like to use purple because purple and perfect squares start with B. So that's what we're looking at. So now, with that in mind, I'll come back. Trust me, we're going to come back to that a lot. We're going to be working on pages 3 and 4 here. So again, the regular perfect squares are here for you. Okay? No decimals. So as we do some of these, and I'm going to do a couple up top, we'll do a couple down below here too. So let's play, we'll go in a diagonal here. We'll play 159. Now again, if you think you know right off the bat, go for it. Otherwise, take the next smallest perfect square below your number and start trying them until you find your pair. 4 and 3. Again, the one in the list is the one that's going to break down. The other one will not. And yes, the order matters. You can't do the 3 outside and the 2 in. It has to be the perfect square that breaks down. Because if I'd have tried to do it with the 3, that's a decimal. We don't want decimals, so that's no good. I'm not going to do it. Ooh, big number. Again, as you get used to this, you're going to start finding that you can guess which number it is right off the bat. without having to keep doing this over and over like I am? Again, the one that's in the list, that's the breakdown one. One gets left alone. Unless the one you happen to be looking at is in the list. If that's true, you can just take the square root of that and get the answer. There won't be a radical with it. So be on the lookout. If it's a perfect square on its own, you don't have to concern yourself with that. And so we keep looking, and we're like, okay, 80, we got to get below. 64, no. 49, no. Ugh. Is there going to be one? Am I ever going to get the... Okay, there we go. Again, the one in the list breaks down. Square root of 16 is 4. Or if you would have happened, as we were going to look at it and do with the little mini list, right above the 16, there's the 4. That's where it's coming from. We can back up, sure. Okay, 64 is going to be 8. Have you messed with it at all on 6? What goes into 60 that's in the list? There is a number. Yes. Yes. 4 and 15, yes. That's the problem. Yes. We always, again, well, even if you did put the 15 on top, it's whichever one of your numbers is in this list. That's the one that's going to come out nice. Because you're right, the other way it will not come out nice. So you're like, okay, that part maybe, we'll kind of figure it out as we go. But what's this craziness you've got down here at the bottom? Okay, that negative is like having a -1 outside. I'm still going to start with what's inside, though. I'm going to start dividing those numbers in. It is. The square root of 4 is 2. The 10's still in radical jail, but remember, the -1 is lurking. They're not in radical jail together. We can. So once you break down the radical, you multiply it by the number on the outside. And if I just see a sign, it means it's 1 that's hanging out there. But the negative still matters. Yeah, the number inside the radical, we're still going to break down, just like we did on the top part. Nope. Just the outside stuff. Yeah, what's under that radical, once we break it down, is not going to change at all. Ever. With what we're doing. At least not yet. Oh, we got to play with one more. Got to play with one more. Let's play with 14. Get my list up here. Again, just the radical. Just the radical. So I'm looking at my numbers. And I start to play. No, everything's decimal so far. Okay, there we go. The 9's the perfect square in the list. That's the square root. But remember, there's still a number lurking. It says, hey, 3, you're out of radical jail 2. Nice to meet you. Let's get together. And we get that set. Now, reminder. Like, Hardy, why do you keep putting systems of equations on every single one of these? Because this continues to show up in several places. And remember, I'm just going to say this. Try adding down first. Adding down. And if you get to something right away, if you have a variable and a number, that's cool. You go ahead, you find that. But there's 2 variables. So for part 2, you can take either equation. I tend to always go to the top one. Depending on what variable it is you found in the first part, so I got x here, I'm going to replace the x with that number. Because now we're just doing a regular old 2-step equation. And divide by 3. But if all your variables cancel on the first step, if you get the same thing on both sides, like 0 equals 0, it's infinite. If you get 0 equals any number besides 0, it's just no solution. So we're just kind of trying to drill that in as we go. If you didn't finish the radicals from yesterday, good time to do that. It's fresh in your mind. But break some of these down. The answers are online. I got them up front too. If you've got questions on those or even the stuff we just got done with, I am here to help if need be. You do have answers here on the back as well, so keep an eye out for those. Let those help out some as well. But I will give one last bit of advice. Some of you have found the answers online to be tempting as I'm just going to jot these down and then I can turn them in. But that's not a major part of your grade. You've got to practice this on your own. Okay? You can do this. You can. But you might have to fight through it a little bit, and that's okay too. So,